I reviewed one of these worthless LED lights a while back, and they certainly haven't gotten any better. And I've had several people ask why I didn't try to repair one. So I figured the next time one of these failed, I would try to somehow make it better. We shall see. When you're working on one of these projects, you have to shoot the video as the project progresses. Otherwise, it becomes impossible to back up and start over with the videos. The remainder of this video shows different things that I tried using LEDs to salvage this fixture. And they all worked, but they didn't necessarily work to my liking. So this is part one of what I tried, not necessarily what you should try. So watch this and learn from my endeavors and, if you will, my mistakes. I made a holder for some LED strips. There's also an alignment pin, and that centers that exactly. Then you can use double-sided tape to glue it down to the surface, or a few screws from the back side. Now this holds 12 of the LED strips. The first strips that I bought are bright white, and I have tried these and I think they're too harsh. I have ordered some that are warm white. But I'm going to put these on this one. This holder is a little bit too thin, but it'll be perfect for testing these strips. And these strips go on these pins. And then there are these little retainment washers, or attachment washers, that goes over that pin. I have a video on welding PLA, or PETG. I'm going to push down on that pin and just put a drop of that solvent on there, and that will keep that strip in place. All these strips had some 3M double-sided foam tape. I have taken that off. And then you can remove that adhesive with mineral spirits. There's a threaded tube that goes down through the center, and that's what holds the glass dome in place. These wires will clear that, and this wire will go through this little key slot over here. These, you'll have to push in, either tape them down or whatever. You don't want these to get up here and cast a shadow on the inside of the dome. This is running on 8 volts right now. These are rated at 12 volt, but I'm going to try and operate these at 11.5, and if anything, that should extend the life of these LEDs. So there's 12 of these strips, 3 LEDs per strip. There's 36 LEDs. This original piece had 33 LEDs. You can see these are actually a little bigger, but I suspect they may have been running these at a higher voltage to get more output, and that might be part of the reason why they failed. Who knows? Made in China. But so are these. So this is a bright white LED. This is warm white. I made another base. These will hold some round LEDs. This alignment pin, again, will center that exactly in the center of this base. These LEDs are bright white, as these were. Again, I think it's too bright. But I put those in place and I glued them in there with a glue gun. We'll wire that up and see what it looks like. And then I've got some others. This is warm white. This is more like an incandescent light bulb. They will go in there. And again, I'll use the glue gun. One of these will work on a 9-volt battery. These are rated at 12 volt. I have found they're nearly at full brightness at 10 volts. So I'm going to try and run these at 10.5, 11 volts, and hopefully these will last longer. Time will tell. The plugs on here are T10. You can get a pigtail socket that will push on there. I intend to just wire them together and solder to these pins. And there is no polarity You can put plus or minus on either pin. This is an MR16 or MR11 plug. This wire is very light. I'll bend it out. And I just straighten that wire. And I cut this off. These have been attached with what appears to be very similar to a glue gun material. You just want to be careful. Don't cut anything that you don't want to cut. Just wiggle this gently. And gently pull that off. Occasionally, you may have one break off. That's not a big deal. Just solder it back on there. This is the center post that was in here, and it captures the glass dome. When I reviewed the first one, these were threads, and there was a screw-on fitting on the top and the bottom that you could take apart. I guess the Chinese decided they didn't want people to take these apart, so now they use these push-on things. This is not a thread. These are just ridges. And this pushes on, and it goes click, 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 click until it's tight. There's kind of a foam washer under there. And then the same thing on the bottom. This goes through the metal. This piece goes on there, and then there's another push-on fitting and another rubber washer in here. And this creates a little gap so that there's a little key slot here so the wires could feed through there and come out on the other side. In order to get that apart, I had to cut these. And I had to cut the one on the bottom too. So this is no longer usable. I've designed a new one, and these screw on here. There's now a notch right here for the wires to pass through that key slot. And on the bottom, there's a matching washer with a slot. And then you screw this on, and you just have to hold that, and you just want to very gently snug that up so the wires can come from the top, and they will pass through that hole and come out on the bottom side. And then the glass dome goes on here and is captured by this nut. I wired this together, and when you attach this, you want to use this alignment pin. This is the bright white LEDs. I'm still waiting for this same type of warm white. And I have wired these. This is another bright white, and these are the warm white. Hopefully between those two different configurations and the two different LED types, one will be bright enough and of the correct color. After the LEDs are in there, you put the glass dome in place. And you can put one of these washers on there if you want. Don't really need it. And then screw this on. Once this captures this glass dome, there's a short threaded rod that this goes over. And then you put a metal washer and a nut on here. And then the job of this center post is done until such time as you decide to remove this light again. So when you tighten this, you do not want to over tighten this and possibly cause this to fracture. And if it was going to break, it would probably break at the beginning of one of these threads. That just has to be just snug. And the same way with this here, just snug. I've increased the dimensions of this as much as I could to make it a little stronger, because this is nylon and this is a highly laminated 3D print. Do not over tighten it and it will serve you well. This is a 3/8 inch diameter all thread tube. This is a standard piece of hardware for making table lamps and ceiling fixtures, and it's been around for decades. Nothing has changed. And when I was making this piece for that lamp, I checked to make sure it would go in there. This was mounted up on the ceiling, and when I got ready to put the lamp in place, lo and behold, it won't go in there. This is slightly oversized. Now, I had checked the acorn nut, and it would fit onto this piece as these nuts fit onto this. But this is oversized. So you may find it necessary to go to your hardware store and buy a piece of this and make sure it fits in here and cut it to the necessary length. I do not want to make this hole any bigger because this is already right on the edge of being too weak. So be advised. The warm white bulbs showed up, and these actually have 6 LEDs on a strip, whereas the bright white had 3. I didn't know that when I ordered them, but that's fine. And you can see the color difference in those. Of the 4 configurations, this is the one I like the best. This puts out a lot of light. After I put this together, I put it on my power supply, and at 11 volts, this draws 1 amp. I have an LED driver, and it's rated 12 volt DC, 1 amp. But when this is connected to these LEDs, it's putting out 11 volts, and from the power supply, I know that that draw is 1 amp. And this is attached to this surface with double-sided tape. Now, in my situation, the way my house was built, the trusses ran over here, and that's where my electrical junction box is. So I have this light mounted off center, so it just covers that junction box, and it puts this centered over the sink. So this is actually going to be up against the drywall. And I'm just going to put a piece of a beer can. I'm going to hold that in there with a couple of pieces of double-sided tape, and that will just give me a layer between that box and the drywall. I don't think this is necessary, but I'm going to do it anyway. When I put the dome on there, and I ran this for somewhere between an hour and a half and 2 hours, this glass is getting quite warm. So these do put out quite a bit of heat. And this driver gets warm. So I think it will be satisfactory. So the original light had 33 LEDs, and now I have 72. I have double-sided tape on every other one of these and some around the center. And I use that alignment pin, so when I push this down, this was exactly centered. And I just take these wires and push them into that center. And on these, you take one wire and you loop it under this mounting ear, and you take the other one and loop it under that way. That keeps it out of the way of the dome. And when you turn this on, you will not get a shadow of the wires. Now, I chose the warm white LEDs that are in here. To me, it's the best color. Color choice is a personal preference. I like this color and I like this arrangement, I'm using this over the kitchen sink. If a light goes out in the laundry room or something, I'll use one of these. I already have them made. The original fixture, these wires were going through there and they were 110 volt. And what I have going through that key slot now is just 12 volt, or actually 11 volt, but it's low voltage. But I took that fiberglass tubing that was around these wires and I used it going through that slot arrangement that I've made. You didn't need it, but I had it, so I used it. These are very bright. You want to watch your eyes when you turn these on. I was happy with this arrangement, and I installed it above the kitchen sink, and personally I thought it was bright enough. My wife did not. She said it needed to be brighter. I really couldn't use any more of these. This is about all I could get in here in a neat arrangement. And it's not as bright as the original. This original had a heat coupling compound on the back that was attached to this base, and this whole base was acting as a heat sink for all these LEDs. This arrangement was not bright enough. It would certainly be bright enough for a lot of installations, but not over the kitchen sink and not to my wife's liking. So I made a change to this. Now the first one I made was printed out of PLA, and this was bright, 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 but it was also hot. And I immediately found out that putting these in with a glue gun was a mistake. It was getting hot enough to where it was melting the glue from the glue gun. And the PLA was getting too hot. So I changed it. I deepened these sockets to where these LEDs would drop down a little further, and I made a retaining ring. And that would snap down on there, and I came back with some solvent. And again, I have a video on how to chemically weld PLA and PETG. This fixture was printed in PETG, and so were these little retainment clips. You push that down on there and put some of that solvent on these four corners, and that held that very well. But again, this gets very hot. I was using this power supply. This is 12 volt, somewhat adjustable. This is rated at 5 amps. And I cranked this down to 11.5 volts. This was drawing 3 amps. I tested this for several hours. This was bolted to this frame. I found out that using double-sided tape was another mistake. Like I say, it was very bright, but it was too hot for my liking. Part 2 of this series forgets about using these LEDs, or these, and goes back to a more standard way of lighting and salvaging this fixture.